Hello grade 3, how are you doing? I hope everything is fine and okay. So today we have unit 9, lesson 4. So we're gonna start. Please open your page 380. So today we're gonna talk about physical changes as well as chemical changes. So we're gonna start talking about physical changes on a matter. So what is a physical change? Actually, in a physical change, the kind of matter stays the same. Folding, tearing, cutting are all physical changes. So what does it mean? It means when I have a matter and I want to change its physical, like its physics, how it looks like, we're gonna change it. For example, imagine you have let's say an orange and you start tearing it and peeling it. But what are you gonna have after tearing it or after cutting it? Your apple or your orange. You're gonna still have your apple when you cut in an apple, and you still have an orange while tearing an orange. And if you have a tacos, for example, if it's your favorite food, while folding the bread, you're still gonna have your tacos. It's not gonna change to something else. So this is what is a physical change. If I have this pen over here, if I will break it into two pieces, it's gonna stay like the same. It's gonna stay a pen. It's not gonna become like an eraser or a sharpener. Okay, it's gonna be just a broken pen. But it means that the physical change, how it looks, it's gonna change. It's not gonna be the same anymore, but it's gonna be the same thing. Let's revise this. If I will break this pen, it's not gonna look like this. It's gonna look like two pieces, okay? So it's not gonna look the same. It's gonna look into two pieces, but it's gonna stay the same. If you're gonna see it, you're gonna tell me this is a broken pen. You're not gonna tell me this is a broken pencil or this is a broken eraser. So it's gonna stay a pen, okay? Anyway, so the same thing with any other matter that we can break or fold or tear or even peel or cut, okay? If you have this paper and you're gonna cut it, it's gonna stay a paper, but like it's gonna be divided into pieces, okay? So this is what is a physical change. It changes how it does look, but it's not gonna change it's not the item not gonna change. We're gonna still have the same item, the same product, okay? So now we're gonna pass to what is a mixture and what is a solution. Now, briefly, what is a mixture? A mixture is two or more substances that are combined without changing any of them, because no new matter is formed. Making a mixture is a physical change. Here it is. When we have our kiwi, a normal kiwi, we're gonna say this is a kiwi. And for example, a watermelon, you're gonna say this is a watermelon, okay? But when having them here, you're gonna say that it's a fruit salad. When I will ask you now, what is this? You're gonna tell me kiwi. I will say, what is this? You're gonna tell me watermelon. I'm gonna ask you, what is this? You can tell me like, it's a mango. Okay, what is this? It's pineapple. So you still know what are they, even though they have physically been changed. Okay, this is not a normal kiwi because we cut it, so we have only a piece of kiwi. So you got it? When we mix everything together, they gave us a mixture. Now, what is a solution? In a mixture, by the way, I can know that this is a kiwi and this is like a watermelon and this is pineapple and this is mango. But in a solution, we have here, a solution is also a mixture. So a solution is a mixture in which all the substances are evenly mixed. Okay, like what? Like salt and water. Now, if I will give you a cup with salty water, I'm gonna tell you what is this, you're gonna tell me water. You can't see salt with your eyes. So for this reason, we're gonna call it solution, not mixture. But it is a mixture because we mixed salt and water. If you taste it, if you drink it, you will tell me that it's a salty water. For this reason, all solutions are mixtures. Same thing if you mix sugar with water. Yes, it is a solution because all the tiniest parts are evenly mixed together. I mean, the sugar is mixed with the water and they dissolve, so you can completely mix or dissolve one substance in another, but it's still, even though it's a solution, but we can call it a mixture because remember, this is what new in this lesson, that you should know that all solutions are mixtures, okay, even though they dissolve together. So here lemonade is one kind of, they're asking us in here, lemonade is one kind of mixture, okay. Now, to make lemonade, you sugar and lemon juice in water. So to make lemonade, we dissolve. You know what is dissolving? Is when we mix, we completely mix until you don't see any parts. Like when we mix the salt with water, or your bag of tea in your water, or like coffee in your water, or sugar in the water, or your hot chocolate with your milk, it dissolves together, okay. Now in a like lemonade, substances are evenly mixed. So when something is evenly mixed, we call it solution. Say this with me, solution. So when something is evenly mixed, we call it a solution. Now we know what is a mixture, we know what is a solution. I want to talk about how we can separate things. So I'm going to take this small example or exercise here to explain it. When we have here some metals and some other kind of plastic things, if I want to just separate them, I can use a magnet, okay? I will use a magnet. Same thing here. A magnet is used to pick up matter that contains iron, okay? We have here a giant magnet separates iron from plastic. So we want to separate iron from plastic, we use magnet. Now here we have like coins and some bottle covers, let's say. How we can separate them? Let's just think about a solution here. Actually, what we can do is we can put them in water, because some of them gonna sink and some of them gonna float. Like this, we can separate them easily. Okay, we're gonna put them in a pot full of water, and then we're gonna separate them, because some of them they're gonna sink down and some of them gonna float up. Okay, now here we have as you can see, sand and some. Now for separating the sand and the shell, the shells over here, we can use a sieve, for example. What is a sieve? Actually, if you can see in this picture over here, this is a sieve. Matter that is smaller than the holes passes through the sieve. Matter that is large than the hole stays on the top. So this is the sieve, okay? It can call it simple tool that people can use it. They put everything up, so the tiny thing's gonna go down and the big thing's gonna stay up over here. So the same thing, we can use it here for the shells. So for not wasting the time writing, just let me show you what I'm gonna write. So we're gonna use here a magnet, and here we're gonna put in a bowl of water, so some gonna sink and some gonna float, and here we're gonna use a sieve. Okay, now we're gonna continue. What is a chemical change? Basically, we just talk about the physical change, and that the physical change only change how something looks like, but it's gonna still be the same product or the same item. Now in a chemical change, new kinds of matter are formed. Okay, how teacher, new kind of matter are formed in a chemical change. Actually, in a chemical change, like we have this wood over here, this piece of wood. Wood burns. What we're gonna have when they're gonna burn? Look here, we didn't cut, we didn't fold, we didn't tear, we didn't do anything. We burned now. While burning, actually, we don't have a physical change, but we have a chemical change. Why? Because new kinds of matter, which are smoke, ash, and the charcoal, which is a substance, are formed. Now here, the ash and the smoke and other chemicals, they're gonna be formed. Those chemicals, we can see them here, even like the color changes, the way how it looks like change, and the substances, the chemical things also change. This wood is not anymore gonna be used, not like this one. So for this reason, we call it a chemical change and not a physical change. It's changed completely. Now I will give you another example to understand this even more. Make him this beautiful bagels. So those are bagels. We can talk about like donuts or anything that you want to do. When we do or when we make food, actually when we make some kind of food, we have some chemical changes when we bake. Actually, why? Hands and kitchen tools cause physical change. Okay, when we use our hand, we're just changing and forming the dough as we want, okay? And when we are using the kitchen tools like the knives and those like spoons and those kind of things, we only change the physical a physical change. It means we only change how does something looks like. But the yeast and the heat cause chemical changes. You're gonna tell me, teacher, what is the yeast? Actually, it's just a product that we put into our dough so it gets like bigger, okay, before putting it in the oven. Like you can ask your mommies how it looks like. I'm sure everyone, you have it in your kitchen, the yeast. Okay, it's just a powder that we mix it with the dough, so we have our dough gonna get bigger. Okay, so when we put it in our cake or in our dough, like our bread or anything, it makes it like look like bigger. Okay, so for this reason we use it. And the heat as well, which is when we put it in the oven. So what happens is we have a chemical change here. Why? Because actually the substances, they differ. Now this dough over here, which is not cooked, is it like this dough over here that is cooked? No, here we have a mixture of flour, water, the yeast, and a lot of things. We mix them together, so they give us this dough over here. But here we only have something that is called bagels. Okay, it's a new item that we can eat. Here we can't eat it, it's still a mixture. But here it's a new matter, it's a new item, it's a new thing. So it's our bagel. So here we have a chemical change because it turns from a dough into a yummy thing that we can eat. Okay, so yeah, that's it for chemical change and the physical change and the solution and the mixture. It's super easy, super fun. Hope that you understand this. Thank you so much for watching. Please try to do this exercise by your own, and I'm gonna just picture the answers and send them to you. It's very, very easy. You're just gonna match. Tearing an object is a, and you're gonna just see where we're tearing an object, for example, and you're gonna say here that is a physical change. Basically the answers are written down here. If you flip your book, I'm gonna show you a secret that I didn't want to show you, but let's see here. We have our answer key, okay, for number 1, number 2, number 3, but don't cheat. Do them by your own first, and then you can correct for yourselves. And that's it, grade 3. Thank you so much for watching. See you soon. Goodbye.